there, and welcome to the video. In this video, we are going to talk through the idea of similar shapes in mathematics. We are going to focus on finding lengths and problems involving lengths within similar shapes. So this topic does get extended to look at area and volume, but this video will focus on finding missing lengths from similar shapes questions. Okay, so here's a very typical question, very basic question to get us started. So when you're given two similar shapes, so I'm told that these shapes are mathematically similar. So what that means is that one shape is an enlargement of the other. All of the angles in both shapes will be identical, but the lengths of each side can differ. So what we're saying is these two shapes are similar. They are not congruent, they are not exactly the same, but they are similar in the respect that their three angles are the same, and one is an enlargement of the other by a certain scale factor. And it's that scale factor we're going to focus on. Okay, so we know these two shapes are similar. And if we look at this length here, we've been told that it's 6 centimeters. If I look at the corresponding side on the larger triangle, we can see that it's 12 centimeters. So we went from a length of 6 to a length of 12. So what we've done there is we've multiplied by 2. So that's telling us that the scale factor from enlarging this shape to this shape has to be 2. So these similar shapes, this one is an enlargement of this one by scale factor 2. I'm going to refer to that as the linear scale factor. Because we're dealing with sides and lengths, and that's what we're focusing on here, I'm going to refer to it as the linear scale factor. So the linear scale factor in this problem is 2. So now we know that to get from here to here, we use the linear scale factor 2 and we multiply by that scale factor. We can go ahead and find x quite easily. We take this length, number 8, 8 centimeters, we multiply it by 2 to tell us that this corresponding length labeled x would have to be 16 centimeters. So we've used our understanding of what similar shapes are to find the scale factor, the linear scale factor, then we've applied that to solve the problem. Very simple example there. We'll start to get a bit harder as the video goes on. Second example here. So again, we are told that these shapes are similar. So we can assume that all three angles are identical, but we can tell from the images that this one is an enlargement of this triangle. First thing we need to do is work out the linear scale factor, the scale factor. So we've got this length here, and its corresponding length is here. So in order to find the scale factor, I'm going to take this length and divide it by this length. 7 divided by 5 is going to tell me that my scale factor is 1.4. So if I took 5 centimeters, multiplied it by 1.4, I'd end up with 7 centimeters, which means I can go ahead and solve the problem. If I know this length is 9 centimeters, and I'm dealing with a scale factor of 1.4, I'm going to take my 9, multiply by 1.4 to solve my problem for y, which is going to tell me that the length of y is 12.6 centimeters. So quite easy to solve the problem after we know what scale factor we are dealing with. So here's a third example. Remember, you do have the ability to pause the video. So if you want to have a go at this question before my explanation, then please go ahead. So again, we're dealing with shapes that are mathematically similar. So these shapes are the same shape, but not necessarily the same size. So 4 angles are all identical, but the shapes are not necessarily the same size. And we can see that from the image. This shape here is an enlargement of this shape here. So first thing we're going to do is we are going to find the linear scale factor. If we look at the corresponding lengths on the base of the trapezium, we have this length of 15 and this corresponding length of 6. So I'm going to take 15, divide by 6 to find that my linear scale factor is actually 2.5 in this question. If I used 6, multiplied it by 2.5, I would end up with 15. So now I'm going to use that scale factor to answer the problem. But this time you'll notice that the unknown value, what we're trying to find out, it's on the smaller shape. So this time I need to take the corresponding length, which is 11, and I'm going to divide by the scale factor. So I'm going to take 11 and I'm going to divide by 2.5. So once I go ahead and do that division, the value of Z is 4.4 centimeters. So I've approached the question in a very similar way. I've aimed to work out the scale factor first, and then I've used that to answer my problem. But because I'm going from the larger shape to the smaller shape, then I'm dividing by the scale factor rather than multiplying by the scale factor. Okay, again, if you want to go ahead and answer this question yourself, please pause the video and I'll just talk you through how to answer questions like this. So this time we are given shapes that are mathematically similar. We're told that in the question. This is a very common exam question. One shape is inside of a larger shape. So what that's telling us straight away is that this angle on both shapes must be equal, but also because we have a right angle and a right angle here, all three angles in both triangles are the same. So that's telling us the shapes are similar. The question does tell us that in this instance, but even if it didn't, we could work it out by showing that all three angles are the same. If I ever get a question like this, how I like to approach it is to separate the shapes and to present the question in an easier way. So I'm just going to draw out this question with two separate triangles. There we go. So now you can see it looks a lot like our examples on the first three questions. And I've just taken all my information from the original question and labeled my triangles. Just make sure that I remember to add 7.2 and 6 to get the full length of this hypotenuse, which would have been 13.2. Now I'm going to go ahead and work out the value of x. First of all, I'm going to find my linear scale factor. 13.2 divided by 6 is going to tell me the scale factor I'm dealing with, 2.2. So if I was to take 6, multiply it by 2.2, I'd end up with 13.2. So now I'm going to use this value to find the value of x. Again, my unknown is on my smaller shape, so I'm going to take 8.8, I'm going to divide by 2.2 to find the value of x, which in this question would be 4. So once we write the question in this form, it's a very similar approach to what we did in the first few examples. There's another question. Again, pause the video if you wish to have a go at this question yourself. So again, the question tells us we're dealing with similar shapes. But we could work that out from looking at the fact that all three angles in the smaller triangle and the larger triangle are going to be the same. We have a set of parallel lines down here, which is telling us that this angle and this angle are equal, and this angle and this angle also equal as well. So what I'm going to do is I'm going to separate the question and I'm going to draw it out so it's a little bit easier to visualize what we're working out. So I've just separated the question up there. Again, just remembering to add 3.4 and 0.68 together to give this full length here. Now I need to go ahead and find my scale factor. 4.08 divided by 3.4 is going to tell me that my scale factor is 1.2. So if I took 3.4, multiplied it by 1.2, I'd end up with 4.08 centimeters. So now I can go ahead and find the solution for y, the length of y. The letter is now on our larger shape or enlarged shape. So I'm going to take 4, I'm going to multiply it by the scale factor of 1.2 to tell me that the value of y is 4.8 centimeters. So again, my original question could have been a little bit misleading because one shape is inside of the other shape. I would always approach it by drawing out your separate shapes, then having a go at working out the scale factor, then using that to solve your problem. Last example from me before I give you some to work through yourself. Pause the video if you want to go ahead with this question before I explain it. I'm going to approach it in a very similar way to the last two. The question tells me that the shapes are mathematically similar. One triangle is inside of a larger triangle. So I'm just going to separate the question out. So now I have the smaller triangle has a length of 4 and a length of 5, which I've put in here. And the larger triangle has a length of 9, which I've put in here. And this length here is z add 4. Because we're trying to work out this z value, z add 4 is what I've labeled for this line here. Okay, so this is a slightly different question to what we've had in the previous examples. We're just going to need to do one extra little step to solve for z. First of all, I'm going to find my scale factor. So to get from this line here to this line here, this length here on the enlarged shape, what have I multiplied by? 9 divided by 5 will tell me that answer. So I'm dealing with a linear scale factor of 1.8. 5 multiplied by 1.8 gives me 9 centimeters. So if I go to this length of 4, multiply it by 1.8, I will get the answer for this completed line here. But remember, this completed line is not what I'm trying to find. I'm trying to find z. So whatever my length of this line is, I'm then going to go ahead and subtract 4. So I'm looking for my value of z to be 3.2. So let's go back to that again. This length here is 4 centimeters. I'm going to multiply that by 1.8, which is going to tell me that this full length here is 7.2 centimeters. 7.2 for this whole length here. But remember, we already know that this bit is 4, and what we're actually trying to find is this bit here labeled z, which is why I subtracted 4 from 7.2 to get my value of z at 3.2. So now it's your turn to have a go at a few similar shape problems. I've put 3 questions on the screen. For each question, can you use your knowledge of finding the scale factor and then using that scale factor to complete the question? So could you please have a go at these 3 questions showing me your full working out? Could you pause the video now, please? Okay, welcome back. We'll just talk through question 1. So we have a corresponding length here, 2.8 and 4.2. We know we're dealing with similar shapes because the question tells us they're similar, which means all 3 angles are identical, but the lengths of the sides may differ. If I take 4.2 and divide it by 2.8, that's going to tell me I'm dealing with a scale factor of 1.5. So then I use my 4 centimeters here, multiply by 1.5 to find out the value of x is 6 centimeters. So we're dividing the corresponding sides to get our scale factor, then using that scale factor to find x in this question. For the next question, we're asked to find x again. We are told that shapes C and D are similar shapes. So therefore we have a corresponding length here of 9.6 and a corresponding length here of 6. So if I take 9.6 divided by 6, that's going to tell me that I'm dealing with a scale factor of 1.6. So now I'm going to go to my larger shape. So even though this is on the left-hand side of the screen now, this is my larger shape. And I look at this length of 9, I'm going to divide by 1.6 to get my value of x. So I'm taking 9, dividing by my scale factor to get my value of x, which will be 5.625 centimeters. Very well done if you work that out correctly. If we have a look at question 3, this question's a little bit trickier because we need to bring in another aspect of maths. However, the start of the question is very similar to what we've been doing in the video so far. So if we look at this larger shape, we have this length of 12 centimeters, which corresponds to this length of 9 centimeters. So even though the shape appears to be rotated, we can still do 12 divided by 9 to find our linear scale factor. 12 divided by 9 is going to give us 1.3 recurring. So we may leave that as a fraction, 12 over 9, or we could simplify it down to 4 over 3. But we do have a problem with this question because we know this length, which would correspond to this length. But this is not the length we want to know. The x value is on the hypotenuse here. So what I suggest we do for this question, now we know the scale factor, is we apply a bit of Pythagoras to the larger shape to work out its hypotenuse. Once we know the hypotenuse, then we will divide the hypotenuse on the larger shape by the scale factor to find our value of x. So let's have a little look at that. So we know our scale factor is 12 over 9, or we could say 4 over 3. We're going to do a little bit of Pythagoras on the length of 12 centimeters and 4 centimeters to tell us that the hypotenuse is 12.65 centimeters. So then that will help me work out x in this question. 12.65 divided by the scale factor is going to tell me that x in this question is 9.49 centimeters. Very well done if you were able to answer the third question and you noticed that we needed to bring in Pythagoras to get our accurate result. Very well done. For the next 4 questions, each question is a bit of a challenge question. So as I put each question on the screen, I would like you to pause the video. I would like you to give it some thought for maybe 5-6 minutes. Have a go at answering the question, show me some working out. How would you approach the question using what we've learned in the first half of the video? After you unpause the video, I will talk you through my solution and show you my full working out for each of the 4 challenge questions. Okay, for question 1, could you pause the video now, please? Okay, welcome back. So first of all, I'm going to draw the question out as 2 differing triangles. If we look up here, because we have parallel lines and vertically opposite angles, that's telling us that both of these triangles are similar. This angle here and this angle here are similar due to alternate angles. Same with these 2 here, alternate angles and vertically opposite angles. So I took the smaller triangle and drew it out next to the larger triangle and then took all the information from the question. So first thing I'm going to do is work out the scale factor. 11.2 divided by 4, telling me I'm dealing with a scale factor of 2.8, a linear scale factor of 2.8. So now I can go ahead and try to find x and y. I've got my scale factor, 2.8. So first of all, I'm going to find y. I take my 3.8, I multiply by my scale factor, 2.8, to give me a value of y, 10.64 centimeters. Then to find x, this time I've got my length of 8 centimeters on the bigger shape, so I'm dividing by my scale factor to find x. So I'm going to do 8 divided by 2.8, which gives me 20/7. You may have presented that as a decimal and rounded your answer. So there we go. We work out our linear scale factor 2.8. We use it once as a multiplication to find y, and we use it the second time as a division to find x. Very well done if you were able to get that correct. Challenge question number 2. Again, you're trying to find the values of x and y. Could you pause the video? Give this question your attention for 5 or 6 minutes and see if you can come up with a solution with working out. Could you pause the video now, please? Okay, welcome back. So again, I know I'm dealing with similar shapes. This angle in both triangles is obviously the same because it's the same angle. And then we've got this angle and this angle are the same. We could be dealing with corresponding angles because we've got parallel lines here and here. Again, these two angles need to be the same. Our reasoning could be corresponding angles. So I'm going to go ahead and draw out the question, smaller triangle and larger triangle, and then I'm going to take all the information from the question. So now my question looks like this. Notice that I've got a y plus 5 on this line here. So this length here is 5 and a y, which is why I've ended up with y plus 5. I do have corresponding sides of 15 centimeters and 6, so I can divide those two values there to get my linear scale factor of 2.5. So I'm dealing with 2.5. That means I can go ahead and work out x quite easily. 4 times 2.5 is going to tell me that the value of x is 10 centimeters. 4 times the scale factor is 10. Now I'm going to try and work out y. So I'm going from 5, I'm going to multiply by 2.5 to get the full length of this line. But I only want to know y. So whatever the full length of this line is, I'm going to be subtracting 5 from that answer. So here's my answer here. So 5 multiplied by the scale factor gives me 12.5. But 12.5 is the whole length. 12.5 is the whole length, y plus 5. So you can see I've created a little equation here just to show that I've subtracted 5 from this side and subtracted 5 from this side at the same time. So the length of y by itself would be 7.5 centimeters. Very well done if you were able to answer that question. This is the third challenge question, and again, I'd like you to pause the video, show me some working out, and see if you can find the value of both x and y. Okay, welcome back. Let's have a look at my solution. So I'm dealing with similar shapes. This angle is the same, and we know this angle and this angle is the same. We could talk about corresponding angles here. We have a right angle and a right angle here, which are obviously both 90 degrees. Corresponding angles also would work there. So I'm going to draw the question out, smaller triangle and the larger triangle. And just make sure on the larger triangle you realize that this length here is going to be y plus 5. So when I draw my question out, it now looks like this. I've got a corresponding length of 10 for the hypotenuse on the large triangle and 6 the hypotenuse on the smaller triangle. 10 divided by 6 is 10/6, which I might have simplified down to 5/3, 5/3. So I'm dealing with a linear scale factor of 5/3. So now I can go ahead and work out x. 8 divided by 5/3 is going to tell me the value of x. 8 divided by my scale factor gives me 24/5, which I can write as a decimal, 4.8 centimeters. So this length here is 4.8 centimeters. Now I'm going to work out why I'm going from the small shape to the large shape. So 5 multiplied by 5/3 is going to tell me this full length, but then again I'm going to subtract 5 from the full length to be left with just my value of y. Here's my working out. So I'm going to do 5 multiplied by my scale factor is going to give me the full length of y plus 5. So that means the full length of the line is 25/3. That's the full length of this line here. But I only want to know y, so I've subtracted 5 from each side to be left with 10/3, which is a decimal, 3.3 rounded to 1 decimal place. Again, I've set up a little equation at this point just to show mathematically how I found my value of y. Okay, last question to have a go at, challenge question 4. Again, could you pause the video, have a go at the question, trying to find the values of x and y, showing me your full working out, and then I'll talk you through my solution. Okay, welcome back. Again, we're dealing with similar shapes, this angle and this angle being the same, this angle and this angle being the same, and of course this angle being the same. This line and this line are parallel, so we can talk about corresponding angles or corresponding angles just to prove the similarity in the question. I'm going to draw out the question like I have for the previous 5, separating the question out, remembering that this will be y plus 4, and this length here is going to be x plus 3. So when I do draw my question out, it now looks like this. I can still approach the question in a similar way because I've got 2 corresponding lengths, 8 and 6. 8 divided by 6 gives me 8/6, which I could simplify down to 4/3. So my linear scale factor, the scale factor in this question is 4/3. Okay, so the next value I'm going to try to find is the y value, and you can see I've got my answer as 4/3. So I've taken this 4 multiplied by 4/3, which gives me the full length of this line being 16/3, but of course I don't want the 4, I only want the y, so I've subtracted 4 from each side, and I'm actually left with 4/3 as well. 1.3 rounded to 1 decimal place. So again, setting up a little equation at this point. Now, if we look at my x values, I'm definitely going to need to think of an equation to approach this question. I take my value of x, multiply it by 4/3, and my result is x plus 3. So what I'm left with in terms of an equation is 4/3 times x gives me x plus 3. So that equals x plus 3. So at this point, I can then subtract 3 from each side to be left with 1/3 x equaling 3. But I don't want 1/3 x, I want 1x. So I've multiplied both sides by 3 to be left with x equals 9. So because there was an unknown on this length and an unknown on the corresponding length, I had to look at creating an equation in order to find my unknown value of x, which was 9 centimeters. Very well done if you were able to answer that question and the previous 3 challenge questions. If you've been able to answer all 4 and you were confident with your answers, then that is brilliant. You've shown a very good understanding of similar shapes when looking at lengths.